Okay, so in this video, when you do logical problem solving, and I highlighted some stuff and stuff so we can get over the main concepts. I'm using the notes instead of the PowerPoint because PowerPoint is a bit. I just don't like PowerPoints because all PowerPoint it summarizes the notes. So if you just learn the notes, you're learning everything one time. So what is logical problem solving? So in this topic, you learn about computers, you learn about coding, programming, how they basically make a computer work. Right? That's basically a summary of logical problem solving. So what you need to know what's a computer, literally a computer system. So a computer system is a machine, right? It's a programmable machine that you can program to do specific tasks, right? These tasks can be arithmetic or logical operations. So like if you click a mouse, it does something, or it can be does like maths. So automatically and sequentially. Hey man, my spelling is too bad. Hopefully my English teacher is not watching. Anyways, it is known as a data processor. Okay, so it can do it automatically. All these processes. Now, what it means automatically? When you click a mouse, the machine can do it automatically, like show you what you clicked or so on. Right? Now, it's also known as the data processor. So, what is the data processor? Right? Is these four things here. It means you can input data. You can put data in it, right? For example, you're typing an email. You type in the keyboard. That's an input data. Then processing of data. It processes the text and it shows it. It processes the text, everything from the keyboard, what you're typing, in output. So then now it shows you on the screen your email, and then it stores the output. So if you send an email, it'll store that email on the sent folder. A computer hardware. Now, computer hardware are all tangible things of a computer, right? Tangible things you can touch. Your mouse, your computer itself, keyboard, printer, all that is a hardware. Um, Another computer hardware which is important is your CPU, right? So obviously you can categorize hardware as six parts: input devices, so your mouse, keyboard, and all. Central processing unit, which is the brains of the computer. Memory, which is temporary storage, and then main storage. Output devices are like your printers. Auxiliary, so many English words. Auxiliary devices are like your speakers. Okay, what you hear. So now going into CPUs, the CPU, right? The CPU is responsible for executing instructions such as arithmetic and calculation, comparison among data, and the movement of data inside the system. So when you click something on the mouse, right, the data goes to the CPU, and basically the CPU makes decisions. It's a brain, right? It makes decisions what to show you on the screen because it like takes the code and like basically runs the code, executes the code, and so on. So it's literally the brain of the computer, the CPU. Now, memory and storage is different, right? Memory and storage is different. Primary memory, also known as main memory or memory in general, it's basically memory that is used temporarily. So what it means is short-term memory. For example, if you can put the computer off, right, those memories in short-term memory, which is memory, will be erased, right? Unlike storage. So what does the purpose of memory is? Main memory, same thing. The memory, it's used to store information that can be quickly accessed or used frequently. For example, the CPU. Next to the CPU, there's memory. The CPU will need information very, very quickly that you need in the computer every day. So instead of fetching it from the storage, which is a very, very long way, it stores certain data that you'll always need in the CPU, in the memory. So it just gets stuff from the memory. Or when you have a clipboard, so when you copy and paste, for example, on a computer, when you copy, it's stored somewhere, it's called memory. If your computer shuts down, you'll lose that, right? So that's memory, it's short term, right? Now, computer software, right? So software and program is completely different, right? Program, it's basically a set of code. So all those lines of code, they basically aim to do something, right? So it solves like a particular problem. For example, you create an app. The code over there is like your program, right? Computer software is divided into two things, right? System application software. System software or application software, right? System software, you can also say operating software, same thing. System software basically runs the actual system, right? Your computer. Application software is only meant for applications. So, for example, system software could be Microsoft, right? Apple. Application software can be your Excel, your Google Chrome. So that's for applications, right? System software manages the computer's resources. Very important, right? Your system software, it's basically helps you like to get information from the computer to give you information. They'll give you a chart just now for you to see over here. But now we need to discuss with application software, right? Also, system software can be in three classes. Operating system. So this does the main features of the system. So like when you click a mouse, what it does, system software. System support gives you utilities. So for example, your recycle bin, all that, you need support, whatever. System development is a part of the system software that allows you to customize the software, so to code the software. In your computer, there's something called command prompt. You use it to basically change the code of a system. So that's what system development is. Application software. Now, application software, it's used in applications, right? It's split into two things: general purpose software and application system specific software. General purpose software is an application software that can be used for a variety of stuff. If you buy a software for Microsoft 365, you can use Outlook, you can use Excel, you can use Microsoft, you can use PowerPoints. So general purpose, huh? If you buy a software for a particular software or particular application, for example, if you buy an application to do accounting work, that's only for accounting work on that application, therefore it's only specific to that application, therefore application specific software. Application software, system software, and hardware and the user are interchangeably related, right? It makes it very complete sense if you think about it. Let's say you're working with a game, right? Or yeah, a game. If you picture yourself sitting in front of the computer and playing a game, you interacting with the game, which is the application software, which makes complete sense. That's an application. The game is an application. That game needs to basically use the system software. Now, why it needs to use the system software? The hardware which is over here needs the system software. The hardware over here is like the screen or the keypad or the mouse. The system software needs to get all the information from the mouse. Now, if you look at it this way inwards, you got the hardware. So imagine you're playing a game with a mouse. If you click on the mouse, move the mouse, the system software recognizes all those clicks and stuff. It tells the application those clicks to the game, and then it displays it to the user. Makes sense. So from the inner, it's actually better to use from the inner. So if you imagine a person playing a game with a mouse, that's hardware. That whatever you're playing, the movements are recorded by the system software. Then lastly, the application software, and then the user sees all that, right? So that's how it works there. Um, let's see, system software application. Okay. Now, there's features of a computer system. Automation. Automation means it's automatic. Once you click a button, it can do it by itself. No need to human interaction. Speed. The speed, it can be very, very speed. What you process on a computer. Storage, it can be different type of storage on a computer. Accuracy, it's very accurate. Versatility. It can be used almost different wide range of tasks. Right? Diligence and can be very, very accurate. They can't lose concentration. Reliability means accurate, right? Accurate results, right? Vast memory, you can have a lot of memory, right? Now, very important, right? Natural language. Natural language is what humans speak. So, sign language, English, all that are Zulu, natural language, right? It's what humans can understand, natural language. Now, computer language is right. Obviously, your natural language, the computer does not understand, right? Now, back in the days in the past, World War II, there was machine level language, right? Machine level language is the language that machines understand. So machine level language I can actually talk machine level language, by the way. That's machine level language. I'm joking. Machine level language is basically numbers. So 101010. Literally, its language is that 101010. The way the one zeros are connected, it makes a language, right? Now, 1940s, right? They had machine level language. Now, machine level language communicates directly with the computer. But the problem is, after that, they introduced symbolic language. So it's still like a hard language, right? But symbolic language uses symbols to communicate with the machine, with the computer. It's still very hard for people to understand, but a little bit less. It was actually a little bit easier for people to understand because this is very, very hard. Now, machine language level language is low level language. High level language is high level language. Now, high level language means the level is that how it can be understood by the humans. High level, it can be easily understood. Low level, it cannot easily be understood like machines. Now, 1960s is where everything changed. Up to the present time, we got introduced to high level languages. And guess what? This is like your C++, your Visual Basic, your coding languages, your programming language, what we use today. Because when we use these things to code the computer, like Java, programming languages, Visual Basic, the code we write, it can't be understood by the computer, but we have something called a compiler or an interpreter that converts this to machine level language. So at the end of the day, we need the machine to get the machine level language. But that's too hard to get because humans can't understand it. So we created this high level language, right? That we can do in human form, C++, all those Java, all those programming language. It uses something like a translator to convert it to machine level language which the machine understands. Right? So obviously there we go. We convert high level language, which is like our programming language, to machine level language, right? Back in the days they should use assembly language, which uses symbols to convert to machine level language. But assembly level language was still too complicated, right? But now we got to a high level language, which we got programs like coding and stuff that we can come to do to machine level language. This is easier for humans to understand high level language. So assembly language, right? So as I said, back in the days, the closest they came to making machine level language easier was assembly level language. It was still very, very hard, but it was easier than just basically putting machine level language and coding using machine level language. So early programming languages were machine level language, which is symbolic assembly languages. Now a special program called assembler translate the code, right, to machine level language, because all now anything besides machine level language the computer don't understand, you need a translator. Machine level language is a language the computer understands, so very important, right? Always the machine can't understand any language besides machine language. You need a translator to translate it to machine level language. High level language is what we use today, so I told you. You'll recognize this from programming. So your Java, your C++, all your programming language, Python, Visual Basic, these are called high level languages, which is also known as programming languages. Now we write this because humans can understand it. Obviously now we need a translator to translate this to machine code, program, machine level language. Huh? Now, the syntax of your language, high level language to code is very important. So, this is where you get, your print, like how the symbols are, the brackets are, how you actually write the code. That's your syntax. Um, Elements of a programming language are just how English level language, so your English, your natural language has verbs, adjectives, all that. Your programming language, also known as your high level language, will be similar to that. Huh? It'll have like data types, variables, keyword, operations, loops, classes, objects, all that. Huh? So it's like a language basically. Compilers and interpreters are like your translators, right? Both these are your translators. So I told you when you're doing code, right? It's not machine level language. You need a converter, a translator to convert it to the machine level language. It can be two categories, these translators, compilers and interpreters, right? So what are the differences? Okay, easy. A compiler. So if you picture a coder, a programmer, you're writing code on the computer for the game. When you complete the code, so let's say you start the code and you complete the code, right? This code is like 1,000 sentences, 100,000 sentences. A compiler will take this whole code, just a whole when you're done with the code. Take this code, convert it using a compiler to machine level language, right? The difference between a compiler and interpreter is the compiler does it one time. The interpreter does it when you do each line of code. So as I said over here, the compiler works by translating the whole code, the whole source code one time. Interpreter works by executing the code line by line. So what it means, so if you write, when you're doing programming, when you write example, print A plus B, it'll do that one time. The next line you write something, it'll print that one time. It'll execute it one time. So when you do a line and there's an error, it'll tell you one time, listen, there's an error. Compiler, it compiles it one time. So don't translate it while I'm doing the code. Only do it when I'm done with the code. When I've written all my code, compiler compiles it, translates it to machine level language. Interpreter will do it line by line as you write. Literally as you write the lines, it'll do it for you, right? So obviously there's going to be advantages and disadvantages. Compiler will be very, very fast, right? Interpreter is slow because you're doing it line by line. Obviously errors are displayed after the entire program because compilers are only tells you after the program. Interpreter, errors are displayed after every instruction is interpreted, right? So that's good actually. So what are the advantages of a compiler? It can be tailored to specific programming languages, making it implement more compact. So more compact means more like small. It makes sense. It can be used with any language, right? It allows program implementation to be independent of the characteristic host. So it doesn't matter if you have Microsoft, if you have Apple, it can be used any computer. The main disadvantage, right? Disadvantage. It's when a program is interpreted, it runs slower. So very important that interpreters are very, very slow. A compiler compiles everything one time. It's fast, efficient. Interpreter, because it does all the lines as you write, it's very, very slow. Because it needs to really work on it. Yeah? There's three differences between codes. You got machine code, source code, object code. Machine code is the easiest. Machine code is your actual code your computer understands. Source code is the code you write. So obviously you write code, source code, that's the code you write using Java, all your programming language, that's the source code. All those codes you write for a program, that's the source code, all done, that's the source code. Object code, right? Very important. You write your source code, so your code using a programming language. It goes to the translator. So let's say you're using a compiler. You can use a compiler or interpreter to translate it. The compiler and interpreter will translate it not to the machine code first. It'll translate it to an object code first, then a machine code. Why? So, the object code, right, is generated, right? It's an intermediary code. Now, what it means? It works between, right? So once you do your source code, your programming using a programming language, it goes to the translator. The translator translates it first to object code. Why? From the object code, it'll go to the straight machine code, which our computer machine understands. But different systems like Microsoft, Apple, Linux, they need different machine level or machine programming language requirements. So this object code will translate it to the specific machine language, which of that specific type computer you have, right? So this is like another translator to translate the translate. Basically, it translates the translation. So the way the code runs is source code, it goes to your translation, it goes to your object code, and then machine code. Garbage in, garbage out makes sense. If you're a stupid programmer and if you make mistakes in the program will output mistakes. But it's not because the computer is dumb, it's because you are dumb. And that's it for this part of logic.